ceremony, I would like to invite Dr. S. Arun Mehta, convener of the ATAL FDP, to deliver the welcome address.
Good morning to one and all, dignitaries on the dais and dignitaries of the dais and then participants of that FDP program. It's privilege to stand before you today and on behalf of Department of ECE, KLEF, extend my warm welcome to the inaugural ceremony of this AICT sponsored ATAL FDP program. This program signifies our commitment to fostering that innovation, sustainability and advancement of knowledge. I would like to thank the KLEF management to give this opportunity to organize this ATAL FDP program in our KLEF. In this moment, I would like to thank AICT Chairman, ATAL coordinators, selection committee members to providing this opportunity to execute the ATAL FDP program in our institute. Today, we gather here with the shared goal of empowering quality of education and nurturing a culture of innovation and research. Our faculty members are the backbone of our institutions, and their continuous growth and development directly impact the quality of the education we proud to our students of. Our goal is to empower educators and professionals to harness the potential of wearable energy harvesting and storage devices, a field that holds the immense promise for driving innovative sustainability. We aim to explore and develop cutting-edge technology that not only benefit of our institutions but also contribute to greener and more sustainable future. Over of this course, entire FDP program, you will engage in series of comprehensive workshops, discussions, hands-on experience. These activities will equip you with knowledge, skills, and harness to potential emerging technologies in wearable energy harvesting and storage.
Esteemed HOD, Dr. M. Suman, who will share their insights with us.
And the fellow faculty. Good morning one and all, and I just want to express my sincere thanks to the faculty, Arun Mehta and Vivekananthan, for organizing this particular FDP. I also thank the management for giving us the opportunity to apply and get this grant. I wish the participants will get the benefit from this FDP. My only request is try to be regular or sincere for these 5 days so that you cannot miss or you will not miss the topics. Hope you will get the benefit from this FDP, and I wish you all the best. Thank you.
In organizing this particular event, any program, any training program, not only in this university, anywhere you attend, keep one point in your mind, that the goal is just not to providing an opportunity to the faculty member to explore the new technologies in that area. The goal will not be achieved until and unless it percolates down to the students. So it is essential for every one of the participants, whatever the knowledge you acquire in these 5 days, once you go back to your department, once you go back to your colleges, ensure that a platform is established in your colleges such that it will be percolated down to the students. Then only the fruits, then only the knowledge you are gaining will be 100% utilized. I congratulate the research heads, group heads of Advanced Energy Research Studies, and also the Flexible Electronics Division of EC Department for giving the complete support to the faculty members and for encouraging the research group faculty members to participate in this 5-day event. I wish this 5-day event program a grand success, and I expect every participant to fully involve in this 5 days program and get 100% benefit out of that. I thank the organizers for giving the opportunity to me. Thank you very much.
So we are very privileged to have you as the guest of speaker today. May I please call upon Dr. M.V. Shankar to the podium to deliver his address.
Respected Registrar of this university, Head of the Department, and Energy Center Head, then the conference organizing committees, that is Dr. Arun Mehta and Dr. Vivekananthan, the faculty members of the department, EC department, and all the participants and research scholars. Good morning, one and all. I am happy to be here in this prestigious university in the Andhra Pradesh state, which is one of the A++ university. It's very rare in our state. So A++ university, and also ranked in NIRF and many other top ranking in the country as well as world. And I also seen the website, many credentials of the department. The students were placed 100% in for the past several years, and the research facilities and faculty credentials as well. They have several collaborative research projects. So one such is Dr. Arun Mehta, having collaboration with Dr. Sathish, one of the speakers today, with CECRI Karaikudi. It's really an excellent ambience to be here in this campus. So a couple of months back, once Arun Mehta invited me to deliver a talk here. So immediately agreed, because I know this university through the newspaper and publications, and not yet visited. So I want to visit the campus. So the first impression is very excellent. The greeneries, the campus is very good, and it's well organized. All the buildings well connected one to other places. And I could see some of the facilities. Being a holiday yesterday, so today we could see the library, huge library and laboratories while entering in this building also. It's really excellent. I'm sure the students and the faculty members are will get a more benefit out of these facilities. As a participants for this today program, many faculty members and research scholars, you will enjoy a variety of lectures. So the faculty members may be specialized in one particular area. So perhaps you will have diversified topics in the coming 5 days for your FDP program. I'm sure you will enjoy, even if it is in the not in the same area. Try to interact with the speakers so that you can get more benefit out of it. So now we are in the electronic era, and we have a lot of information available on the website, in the YouTube, you can get it. But what is the major benefit out of this physically present here in this conference is, so you can have the direct one-to-one interaction, and the understanding also, it can be much more better than just online. In the online, when you are listening to the lectures, you can note down maybe some of the point to clarify. Sometimes we may miss it. But here, so you are not distracted. You will be only on this particular job. When you are listening to some of the lectures, online lectures, you may be working on other, you have to go for the next hour class, or for some research work, or the other meeting in the university or the college. But when you are here, you will be focused on that particular talk, only this particular program. So I heard from the organizers that they planned for some laboratory classes in the afternoon. I think this is one of the different kind of FDP program. They have some journal publications also need to explain, and a variety of things compared to our traditional FDP programs. I'm sure this program will be much more beneficial. I thank the university for organizing such a wonderful program, and also a department for taking all the initiative. Conducting a program and bringing the people together is not an easy task. So, but still the university is putting their effort, and also faculty members. So it's very good credentials for this university. It will be beneficial for the upcoming NAC grade, as well as NRF ranking for this university. Definitely the students will get benefited by interacting with the different type of people. So I request the faculty members or research scholar to interact among each other, so that you can get you may find a new collaborator, or for research scholar may find a mentor. Why not? Some of the faculty member may get a job as either a research scholar or a faculty member working somewhere else may enter in this university. Because recently I heard one of the faculty member from Pondicherry University, he was working in elsewhere in Tamil Nadu. Once he came for this, like you, the FDP program, he liked the university very much. Later he applied and entered into the, joined as a professor in the nanotechnology in that university. So like that, this university, our campus may give more inspiration to you to work more in this topic, as well as joining this elite group in this KL University for doing much more work. So I wish that this university achieve much more benefit out of this conference and encourages the new talent as well. So once again, I thank all the organizing team and the university for giving me this opportunity.
I would like to invite Sir to make few words about our FDP and encourage you people to participate in that FDP program. Sir, I like to invite you, sir. Please, your dice is yours.
Good morning to one and all. Respected Registrar and Head of the Department and other faculty members and colleagues and research scholars and invitees from various other universities and colleges. Very good morning once again. And then it's a very privilege to be here as a resource person, since whether directly or indirectly I'm also associated with the KL University, since I'm hosting Dr. Arun Mehta for last 1.5 years for his TAR fellowship. So I heard a lot about the campus as well as the administration and then the infrastructures about the university. So this is a great opportunity for me to stand here and then see in person. And then really the campus is almost very similar to the IIT campus, though it's the area is small. And IIT Madras campus, if you enter, you can see the lot of trees and the very wonderful roads. And here also, as soon as I entered, I realized almost it's a part of mini IIT, I can say. So you are in a very nice atmosphere. I'm sure that the faculty members also is very supportive and very interactive to you, the youngsters. So my request is to make sure this opportunity to grab some knowledge on these materials as well as the electronics, whichever it's interest for you. I'm sure that I also should appreciate the topic they have choose. So the wearable energy harvesting and storage devices. I'm sure this topic has been selected with a lot of expertise, since this need of the hour to the entire globe. So people are almost last 4-5 years talking about various aspects of energy storage, also harvesting energy from the natural sources, particularly for the sustainable and recyclable energy storage and energy harvesting systems. So as the energy storage person, what we facing the problem is integrating the system. So for example, I'm a battery person. I'm working on batteries and supercapacitors. So maybe I will explain you what is the batteries and what is the supercapacitors. So both are maybe storing the electrical energy, but in different methods. But the applications are different. But we want to integrate these two systems. So for we need really an electronics person as well as the electrical engineering expertise. As a person with a chemistry background and materials expertise, I can able to make a battery, I can able to make a supercapacitors, but I cannot integrate. So this needs another expertise. So this is a different domain. If I want to be a master on that, and then maybe I need to spend another 20 years to learn. By the time everybody will be crossed this. For example, 30, 40 years before, somebody was talking about I can talk to some other person in the world without having any wired connections or nothing. Nobody might be believed. Since that time, since there was no mobile phones, right? So, for example, the mobile phones now removed so many equipments, starting from our wristwatch to the clock, and then there are calendars have been removed, and that conventional mail has been removed. There are so many things has been removed by this mobile phone. So this is not possible unless otherwise the integration of this group of scientists, they have a different expertise. So always I talk to my students, so making X to X plus is not a use. So that's called incremental research, that anybody can do it. But if you want to see really a product, there should be a integration of people first, coordination of people with a different expertise, then only you could see the real product or usable device. In such a thing, I think this particular topic is very useful for even me to learn many things about electronics and what are the requirements, expertise is available with others. So first of all, we have to find out the right expertise to people to make a team. So I'm sure this particular FTP program will be useful for the attendees as well as for the speakers to identify some new collaborations and new devices. So with this, I once again thank the KL University and its administration, and then the Department of ECE and the organizers for giving opportunity to talk to you. Maybe we'll talk more on the session. Yeah. Thank you.
This topic is highly liked by both scientists and engineers. I mean both science and engineering disciplines, because the photocatalysis is an interdisciplinary topic. First of all, it is easy to understand, not too many mechanisms are not involved, and need a simple facility is sufficient. Like sunlight we have, okay, and we need some of the other facilities. Sunlight we need a catalyst which is a cheaper material, we can able to use it, or efficient material we can able to use it, and we can test it with some basic facility. If you prepare a photocatalyst, and it can be tested for degradation of dyes, and you can check it using just a spectrophotometer. Once you ensure that this material is good, then you can go for characterization and further activities like that. So first I like to say what is if you talk about science, in the science also you know physics, chemistry, it is a partly physics, partly chemistry is there. And then when you're coming for the application, engineering is coming up. So in catalysis is a physical chemistry part. So that is a chemical substance which increase the rate of the reaction without consuming itself. It's a simple term, we can say that. So a lecturer or a teacher as a catalyst, for example, this is a lecture hall, a teacher is entering into that, and many students are sitting here. What he do, he come and teach and then he will go away. Like that, a catalyst, and that is he teach and enlighten the student, giving the knowledge. So, but the teacher may stay in most of the classes, the students may stay in the same classes, teacher go out and the next teacher will come. Like that, the catalyst is a chemical substance which increase the rate of the reaction. Because normally when you mix the two chemical, some of the chemical it will react, like acid and the base, it will react quickly, give the product. But some of the chemical when you mix, it won't react. Even at a little bit heating, it can improve. That is also, it doesn't work out. When you use a suitable material, a chemical called catalyst, which accelerates the rate of the reaction.
Complete the band gap condensate and balance in XPS.
Correct.
Is there any other?
So this is the suitable method. See, valence band, XPS valence band spectra is suitable for valence band calculation. From the band gap and then subtracting this valence band level, you can get the conduction band positions also. This is the only method we are using.
I saw some notation for photovoltaic condition.
Yes.
We can electronegativity. So
Yes.
that method to calculate the band gap.
No. Electronegativity is different and band gap calculation is different. Electronegativity is different. Okay. Band gap is different.
Band, not the band gap. So
Band potential.
Yeah.
Yes. So the electron or hole coming from that band potential only suitable for some of the oxidation reduction reaction. Not all the electron or hole from that particular different energy level, it doesn't have the potential for oxidation or reduction reaction. So we can use it. Electronegativity is different, but for band gap, band potential calculation is suitable for XPS only. Okay.
So this time working on the graphs.
Yes.
So we have mentioned the conduction and balance band values in y-axis in energy.
Yes.
Here it's a potential versus image. What's the difference?
Normal hydrogen electrode. So, and also we have to give, whenever give, yes, I also forgot to say important point, you reminded me. For photocatalytic application, when we say the band potential, valence band potential or conduction band potential, we have to give with respect to the pH. Either pH 0, 7, 10 or 14 it will be there. Commonly these four it is reported. See, same material, the conduction band potential with the pH 0, one value will be there. If you calculate in the 7 or 10, it will be different. Okay, so if you don't give the value, how I can take it? Whether you have calculated in the 7 or 0 or 14 like that. So it must be given that pH value. Normal hydrogen electrode, mostly it is the pH 0. They calculate it. That's like electrochemical analysis, more towards electrochemistry. That. But anyway, anybody can understand, even science or arts or engineering people can catch it. That's very important parameter. It's a very good question. Okay. Oh, right. Thank you very much.
Now I can see, for example, my energy density depends upon how much amount of charges I can able to separate. How much amount of charges I can able to separate is depends upon how much amount of electrons I can move from one side to the other side. Okay. If I have more surface area, I can absorb more size, more number of ions. Okay. So obviously I need a high surface area electrons. So that's why people are trying to make it high surface area carbon for supercapacitor application. But the only thing is, since this entire thing is as an electrode, my carbon should be conductive in nature. Okay. So if it is not conductive, I cannot use it as an electrode. So I need a conductivity, I need a high surface area. For example, this is a very thick, assume that this is a very thick paste. So then the electrolyte has to go through the pores within the electrodes. So that this gets inside the pores also there is a surface. So these ions get absorbed on the surface of the material. Okay. So that's why this surface area plays a major role. I think you are getting sleep, right? Okay.
Different factors of the SC, like electrode material and the electrolyte form and everything. So if we use the gel type of electrolyte, the potential window restricted to up to 1 volt. So that's why we selected one. For other metal oxides, it supports up to 1.5, 1.3. If the potential window is high, energy density will high. In yesterday's class, sir told that E is equal to half CV square. So if the potential window is high, then the energy density is high. So we can also see the material, how to improve the potential window. That is also one research area we can see. That means how to decorate the polymers or any other material to improve the potential window. So the 3 cycles it completes. This is 1 and this is 2 and this is. So this is CD. Any doubts in this? We can start from 10 millivolts, 20 millivolts. Oh yeah. Which voltage? Voltage is constant. Here we are fixing the voltage and we are seeing how it responds, how it produces the current. So how much current I am not observed here in CD. CD at 90 millivolts will be, I'll check once again. So here we are fixing. It starts from 0 to end at 1 volt. That we are fixing and we will check for 0.09 millivolts we are fixing, so that it goes from 0 to 0.9 and slightly. So how much current it produces each? So you see it starts from 15 milliamperes and it's good current. Why? Because polymer is a conducting polymer and only some SCs only produces the microamperes and sometimes it is also nanoamperes also. But this device gives very good, you see, 25 milliamperes. If it is metal oxides that are good conductors, that it increases up to more current. But these are only polymers, no? So that it produces very good current only, 25 milliamperes to minus 2. So this is the oxidation and this is reduction. In previous iteration, the instrument just now started. That's why it gives the hysteresis. Now it gives the oxidation and reduction. So you don't take the first cycle as our output. So that's why we are taking. That's why we are giving a 1, 2, 3. And here is one option is there to select one first cycle and second cycle. I'll show you and we can also observe the how it coming in the cycle 3. So it is segment 1, it is segment 0 and it is. So these are the 3 cycles and we can see every cycle how it exhibits the response. So here we got 15 milliamperes. Here it is. And we can report in the first cycle we got 25 milliamperes and 1, 2, 3. So this device is exhibiting this response after 2000 cycles. Cycling stability is also completed. So every time science telling that we are applying force for 2000 cycles and we are observing the same like that. For this supercapacitor, we are giving different voltages for the 2000 cycles. That means you switch on the torchlight and switch on and switch off for the 2000 cycles. After that, how it becomes CD. Right, this is about CD. Any notes? Okay, next we go for the charge discharge. So it is charge discharge. So this charge discharge current we can go up to the. So what is the maximum current we got in CD? 25 milliamperes. So up to 20 milliamperes we can check the GCD. So here we are in GCD, galvanic charging and discharging. We are fixing the current and we are checking the potential. But how it changes the voltage. Right. So here number of steps are there. So that means cycle. Charging and discharging is.
So most of the issues here will come from only electrolyte. For example, if you use aqueous-based electrolyte, 0 degree electrolyte will get freeze. Even if you use non-aqueous electrolyte, below minus 5 or minus 10, it will get frozen, right? So if there is an electrolyte get frozen, there is no movement of ions. Of course, there is a movement of ions that may not be equivalent to the complete liquid state. So here, materially generally when you reduce the temperature, most of the time nothing will happen. Most of the time. Of course, there will be some kind of material, it may not be stable at lower temperature. But minus temperature generally most of the materials are stable. Only the voltage, the electrolyte may not be stable. So you have to find out some electric solvent or kind of thing so that freezing point will be minus. For example, the army people who are working in the Jammu Kashmir and all. So they need some batteries or kind of energy storage device that should go really minus 10 or 20 degrees Celsius. For us it's not needed. We are always in very hot temperature, right? Yes, both things has to be used. In the two electrode, we have a same material as positive and negative, and then in between you have the electrode. When I am measuring in the three electrode system, only I use only one electrode as working electrode. The other two will be one is a platinum, the other one is a reference electrode, but the electrolyte should be the same. Whatever I am planning to use in my two electrode system, the same electrolyte I have to use. Otherwise there is no meaning in studying in three electrodes. Anything, liquid or semi-solid is also. This case, for example, gel electrode, if you want to work on flexible and bendable devices, you can also go for semi-solid gel kind of electrodes. $2,000. Yeah. So it's for because carbon electrode or carbon medium? It's a carbon powder. Carbon medium is coated with stainless steel. You can form it, it will be changed. No, that is only a powder, 1 gram of powder carbon, which has this surface area. What happens is, nickel form is same once. So it's will be coated means it's a less area, but the stainless steel mix will be taken up more area. So it's change the surface. It's not like that. Even for example, I make a pellet of this carbon. The surface is still available. The electrolyte can penetrate. Okay, the electrolyte can penetrate through the solid. Unless otherwise you completely fuse it, it may be difficult. Or simply I press into a pellet or I paste it on some of this electrode surface. Obviously there is a force. You cannot make it, you cannot arrest the electrolyte to go in. That much is not possible. Even if you coat it some micron, 200 micron thick, also is sufficient. Electrolyte can penetrate and access all the surface. So we are not going to see capacitors using CV or farmers. EC equal to 1 by 2 CV square. So 2 pharma generally used for the calculator associations. Which one is that? No, if you use cyclic voltammetry, that's whatever it may be there, if you calculate the C, the energy density is calculated by 1 by 2 CV square. The C you can calculate in 2 routes. One is by cyclic voltammetry, the other one is the galvanostatic charge discharge. Always galvanostatic charge discharge will be close to the real value. Cyclic voltammetry will be always it will give you the higher values. No, I did not use cyclic voltammetry, just for understanding. For preliminary understanding, I use cyclic voltammetry, but not for using or calculating the specific capacitors. Of course, I can calculate, but that will give you some values, but that is not the original value. 3 electrode values always will be high, and when I make a 2 electrode, it will be less. When I make a real capacitor, that will be far less, 5 times lower than the 2 electrode values. Since when I make a cell, I show you some cylindrical cell. I have to add the entire weight of the device, not just only the active material. Whereas in the 3 electrode cell, I use only active electrode weight. So that will be always in high value. So I am talking at the same time, so CV and GCD means can I keep the GCD values? GCD values are more acceptable. Now these days lot of literature is wrong, okay, long with different calculations, most of them are very wrong. Okay, always if you want to calculate the specific capacity or energy density, you should use only a 2 electrode system. Okay, 2 electrode system, your galvanostatic charge discharge will be the ideal one to calculate the energy density. So some people they will calculate the specific capacitance using the 3 electrode system. That specific capacitor should not be used to calculate the energy density. 1 by 2 CV square, that value if you put, the energy density will be more than 100 watt per kg. So that is far beyond that original value. Original value will be hardly 4 or 5 watt-hour per kg. So this is the complete hydrogen economy. It is very, very crucial. The first one is, so far I discussed about one part. It's not in the one part, in the electrolyzer part, PEM electrolyzer part, inside the catalyst material. So as a chemistry point of view, catalyst is important. As a mechanical point of view or electrochemical point of view, the design of the flow field, design of the cell is important, and testing of the cell is important. So like a power electronics or mechanical engineers very, very play a crucial role for the design of the cell and testing of the cell in this field. And second thing is to bring this one, to run the system, we will take the power from the grid. Instead of grid, we have to take the solar or wind power. So that is why we start from here, and once we generate the hydrogen, so we have to store somewhere. We have to store somewhere means we have to require a storage tank. Once you require the storage tank, you can supply to the gas power plant or power grid. You have to transport the hydrogen from one place to another place. Now, India is making a pipeline to direct Dubai to underground. It is a pipeline for the petrol. Same thing for the hydrogen. It is the first time in the recently, 2 months back, Texas is the first state in the globe. They are working on the development of the transport of hydrogen through pipeline. So that is the one system they are working with. They initiated recently 3 months, 4 months back. And from there we can do the refinery and fertilizers. So hydrogen, if you take the fertilizers, it is completely hydrogen is required. There is ammonia, is the playing vegetable. Where we can supply this hydrogen directly to the fertilizer. And this is the another part. Once we disperse in the system, like a petrol CNG pump is there, CNG or a car and bus, two-wheeler, three-wheeler, and four-wheeler, automatic CNG cars. How they are using the CNG station. Same thing in future, we have to dispense in the develop the dispensing system of the hydrogen. From there it will go for the fuel cell vehicle. And one more thing is, like Arabic countries, we will develop one huge amount of hydrogen we are generating in India. Same thing we can transport the hydrogen from the other countries by through shipment.
Sir, myself A. Vivekananthan, PhD scholar at SRM University. I would like to ask how about safety of storing the hydrogen in moving cars and also. Some people are talking about storing hydrogen in solid forms. What about your perspective on that?
So generally, so that's what IIT Roorkee, Professor Pratibha Sharma, she is the professor in the Indian Oil Corporation. Already I told only 2 groups are working on the hydrogen storage systems. So generally hydrogen is stored around 700 bar temperature. So you require a type of cylinders, like a metal cylinders are the safety compared to the normal cylinders. So that's why they are working on this different pressure systems. They are working on this pressure stage only. So they will bring it to some solution for this one. So come to the solid hydrogen point of view. So come to the solid hydrogen point of view. It cannot happen, 2 reactions cannot happen under our Evolving vehicle. So people are talking about the hydrogen storage systems, and solid hydrogen is mainly useful for the transport of the hydrogen.
Okay.
It's a 6 to 10 times more. That's called sodium borohydride transport they are asking. And it is a like UCL London, University College of London they started, and some Malaysian companies they started on this solid state hydrogen. Yes, please. Yeah, please.
What is the basic infrastructure required to blend H2 into methane?
So the basic infrastructure means, for example, for now all the CNG cylinders, what you saw in the CNG vehicles,
Yes.
it requires, they are operating nearly 120 bar. So it is stand up to 350 bar is the maximum capacity, but at present up to 120 or 150 bar is operating. So even input of hydrogen, if it is stand more than 150 bar, you need an inbuilt has to be imported. So that is the new technology. It will require high 700 bar or 600 bar compressors. Where blend this hydrogen to the CNG.
And one more doubt, sir. What is the purpose of power electronics in the fuel cells?
So like if you once you develop the fuel cell, so we want to convert to some load, we need an interface like a DC-DC converter or push stopper or fuel cell management system. It means through computer we have to operate the system like LCD. That all these things comes under this part. Fuel cell is like a battery.
Battery management system?
Yeah, like a battery management system. We have developed is a fuel cell management system.
Thank you, sir.
Based upon that, we can change the electrode also, sir, right, sir? Yes. Or it is the same electrode, ITO. No, electrode can be anything, there's only just charge collecting layers. For any device, you require electrode, right? It can be gold, from the copper, from the aluminum. We can use the same electrode, sir? Yes, electrode doesn't have any issue, we can use same electrode, because it's only just carried electrode, that's all. So same electrode is also? Electrodes can be done, but friction layer should be different. And what is the welding, welding to different, beyond, my understanding, beyond the after a particular level, there is no formation of different energies. So what is the applicable difference, 1,000 difference? No, that depends on your property chosen. That I cannot do this analyzation. So there is a Triboelectric series. Okay, then we have a standard Triboelectric series which is updated recently as well. You can choose material from the extreme end of the Triboelectric series. One is the bottom end which is more powerful, one is at the negative which is at the half end. If you choose these two materials for the Triboelectric series, the probability for getting more voltage will be more, provided it should have a proper contact with the load for external lines. It's not that if you choose two different materials, you get a higher output voltage. If the contact is not made, you cannot get the output voltage. So, based upon the reference you told that, sir, yes. So, more smoothness you can extract more. It's a simple example. If you take a very two smooth surfaces, the contact points will be very limited. If you take a nanoparticle film on your stem, try to connect it, all the nanoparticles will contact the upper surface, right? So they are getting more contact points. So you can make the same roughness by making some mechanical polishing. You can polish your substrate with a memory paper. You are creating a roughness. That will increase the contact point. You are going to get the better output. That's the main one. And we also done some breath monitoring here. This is done in our laboratory. Where TNG is inserted here on the chest. As you can see, as he's breathing, there are spikes coming here. The spikes are related to the breathing pattern. How small, how slow he is breathing or how fast he is breathing. Okay. So this will be used for the sports person. You need to monitor the breathing pattern for the sports person. So you can implant with this device with the extra circuit for storing the data or the breathing pattern. Later part you can analyze this pattern and you can analyze the sports person breathing pattern. That will be useful in certain, especially the people who are going for swimming and that. Their breathing pattern is very much essential. And you can also use for sleep monitoring. This is work we have done in our laboratory. So where we have implanted TNG device in the pillow. So there is one TNG device implanted here. The one in the photograph is B only. And there are two electrical connections connected to the oscilloscope. The moment you change your head positions, if you are in a deep sleep, you usually don't change your posture. You will do the same position either left or right. The moment you change your head position because of you are not getting sleep, then you are going to see a disturbance in the oscilloscope output. Now it's not coming. The second time will disturb the. So it's very useful application because many people have sleep disorder. So you can implant this device. Now you can see there's a disturbance in the oscilloscope. Now you can also see there's a disturbance. Okay. You can collect the entire night data and you can project it there and you can see whether you have a peaceful sleep, disturbed sleep, where is getting normal sleep, where is not getting normal sleep, what time is having disturbed sleep. So this is very much useful for people who have sleeping disorders, especially. Okay. This is only one pillow. If you want to have a full, like you have more sensitivity, what you can do is you can implant many TNGs across the brain. Okay. So you can have which side you are moving, which side you are moving more side, whether you are sleeping left hand or right hand, all those things information can be calculated from here.
But we are putting the solution, the spark will accumulate in the solution.
positive side is there, negative side is there, but it won't be touched. But it should be finished. It should be finished the circuit. For that, it will create a one vaporized plasma line. That positive plasma will be based on accumulate on the solution from this place. Okay, this place the electrical normally. When we push the liquid to outside means the charge is there now, positive charge. It automatically directly go to the negative electrode, right? Positive to negative will go. Like that it will go means it will deposit on the negative electrode side. Okay. This is the understanding. We are giving the, it won't happen in the small, the plasma it should create. For that we will give the 12 volt, 13 volt, 15 volt, 35 volt, 15 kilovolt, sorry, not volt, kilovolt you will give. Okay. This based upon your material. If your material is a highly conductive material, we will just give 1 volt, 1 kilovolt, 2 kilovolt, apply means you will complete the circuit. It will complete the, it will set the particle to that side. If your material is purely PVA, it's a non-conductive material, or pure water. Or else non-conductive material means we will go to the higher kilovolt, like 50 kilovolt or 45 kilovolt, 50, 60. What is this? Here we are applying 35 kilovolt. That is the maximum. But for our material, if the material don't inside means material is not material, it's only PVA. Okay. Some polymers have in the piezoelectric coefficient, like PVA, those kind of polymers. But PVA is not. But PVA is one of the piezoelectric material. That's why we are taking the PVA as a material. And already we prepared the solution with the DMF and the PVA, 10%, 10%. 10 gram of DMF or DMF solution. 1 gram of PVA, 10 gram of 10 ml of DMF. Like that, 5% we done. Already 70 degrees Celsius we stir for a whole night. It will disperse, it will disperse in this one. So it is like a gel, right? Yes. So how it will become gel? Because we move to here to there. We will ensure that we will collect every place. The same. That's it. Yeah, that is okay. This helps me if you have any doubt on this. It's not any specific reason. Yes, normal insulator is fine. Just aluminum foil is there now every place. That is fine. It's for also conductor, so any that's why we are using. But in small place you won't affect anything. So how much RPM? This is 150 RPM. Yeah, it will solution will accumulate the positive charge. When it is pushed, the positive charge will go to there. Show me this. Yeah. This is a finally outcome, how it will be. This is a beauty of the already did one.
Sir.
Tomorrow we will demonstrate that one. That time I will show how we will do this one. With the beauty of the yeah, super. So how we are using maybe how we extract this one? No, if you want to extract means, you normally you can able to extract. But it is not good to extract from this one. It will come. Okay, it will come like this. But after you the fiber is after you get this fiber, you can't able to place anywhere perfectly. Okay. Like that's why time is that's why what they will do means they will cut this one, they will use because the electrode, it's a material like that. However, you will go to place down one electrode, right? For that we are using this as electrode. More than this electrode you want to connect me, you will go to copper. More than that you won't go anywhere. So where this design is the lay pushed just you can check this one. Here you can find out the charges. So this we can call it as a
flow field. So over this flow field, what we are using, just we are using one, just like it is like a membrane will be there. It's called Nafian membrane. Over that Nafian membrane, they will put a one carbon cloth. In that carbon cloth, so what catalyst you are using, commercial level catalyst or what you are developing some catalyst mix. So that catalyst they will spray on the carbon cloth by using the spray gun. So that overall setup we can call it as a membrane electrode assembly. Where is the membrane will be there and two electrodes. That's called as a gas diffusion layer. Gas diffusion layer will be there and there over which we will put the catalyst. So this is the path. So one side what we do, we will go for a platinum catalyst or indium catalyst or ruthenium catalyst, something they will. Once it is a membrane electrode assembly is over, then they will place like this. They will place like this membrane electrode assembly. Place will like this, and this is the input of the water as well as the output of the water. So this water will be pumped by this peristaltic pump. You can rotate that water 2 ml per minute or 1 ml per minute, 10 ml per minute, like that. The flow rate you can adjust with this pump. Once you adjust this pump, what will happen here? Once you assemble the cell like this is called as the current parameters. So once you pass the water, it will fill the channels and it will exit. So these are the copper is the conductor. Some people will use gold coated copper, or some people will use SS as the correct conductor. Some people will use copper. If you go for alkaline solution, they will preferable for the SS plate. If you are using for the PEM electrolyzer, you can use for the copper is the sufficient. So once it is there, then we can call it as an end phase. Over the end phase, we can put on the FRC gasket. This is a fiber reinforced gasket to minimize to stop the conductivity between the graphite plates and the SS plates. Otherwise, what will happen? Cell will be shorted. So to minimize that one, we will start with the and for the nut and bolt also, there is a over which there is a gasket. It is not direct nut. To minimize the electrical contact, there is a one heat sinks will be there on the nut to minimize the electrical contact. So where we can arrest the contact from here and we can arrest the contact from here. So only thing is we can get the contact from the center. That is called from the flow field. From the flow field means from membrane electrode assembly. So as long as you pass the water, it will enter and it will exit. So when it will break. So for that purpose, we have to give some particular potential to break the water. Generally, if the ideal condition is it will be 1.2 just in an overall reaction. H2 will be there. H2 will be the anode side, cathode side. These are the things will happen. So here, if you as long as you pass water, so there is nothing will happen. If you give some particular potential, the H2 will break, H plus and oxygen. So that OH bond will break, as I already told in the afternoon slide. So this is the old one. This is a new technology. It means where it does not require any titanium gas diffusion layer or something, you can take that carbon plastic. So titanium is too costly. So where we can go for with the carbon cloth also to run, but they are right.
What is the most important component? Is the power source, right? Is the battery, right? So if you don't have the battery, our mobile phone will not work. Okay. Now the problem with battery is that we need to continuously charge it. Okay. Can we think of a device? Can we think of a technology which can harvest energy from the ambient environment and keep on powering your mobile phone? Okay. So people thought of self-powered devices, self-powered electronics, which can generate energy from the ambient environment and power your mobile phone or power or charge your mobile phones, right? If you talk about energy harvesters, there are different types of energy harvesters. Solar cells, mechanical energy harvesters, electrochemical energy harvesters. One of the most promising, predominant, emerging energy technology is mechanical energy harvesters, okay? Okay, mechanical energy harvesters. Now, if I talk about mechanical energy harvesters, right? We wanted to make an energy harvester which is stretchable and self-healing in nature, right? So finally, we made the triboelectric device. Okay, now when I talk about triboelectric devices, triboelectric nanogenerators, it has made significant progress in the last 10 years. Okay, it started in 2011 and now within just 10 years, it can be used in multiple applications. For example, we can use as electronic skin. We can put it on our skin, we can just tap it and it can power LEDs. We can use for wind energy. We can generate energy from the wind. The wind can flow, right? And from the flow of the wind, we can create energy and power some devices. In fact, we can generate energy from walking. We can walk on the device and this can create energy. We can also put that device inside the body. For example, we can put it on your heart, right? Every time the heart beats, we are able to generate the voltage. So it can be used to power the pacemakers. Understood? Okay. Okay. Now you said, how come a polymer is stretchable? How come a polymer is healable? Right? Can any of you name a polymer which is healable or stretchable? Have you guys seen? Yes. Can you guys give an example of a polymer which is stretchable and healable in nature?
That nano-sized liquid space while stretching it is breaking and making a contact between cylinders. After releasing, what is happening?
Excellent question. Okay, excellent question. So the question is, suppose I have two silver flakes, okay? I have a liquid metal particle. Now when I stretch, this particle is ruptured, okay? And is forming an anchor between the two separated silver flakes. Now when I release it, like liquid can take the shape of the container, right? There is a space available, right? It can come back. But what is happening? What is happening is, it is again forming a passivating oxide coating. It is again forming a particle.
So its shape is
Regaining back. Because water can come back. Right? And if you keep it, it will again form a passivating oxide coating. Right? So because of that, it can again regaining its original shape. It's very, very, very interesting question.
iPhone total income in India itself 70,000 crores. 70,000 crores is the income of Apple in India. If that is the case, the overall total earning of Apple is almost equal to Indian GDP. All of us Indian 140 billion people, what we are making, Apple itself is able to make that as a revenue. It's not because of usefulness brought as value. Try to repeat that. That is from my side. So, if you have some questions or something, whatever you would like to.
Any doubts in your like digital scenario, how it is happening, and
whatever the
anything. Now you ask us, I don't know how that water flow, water leakage, people are not caring them how it is to be maintained. Like,
actually, water scattered. Scattered. Actually, these people are explaining that the sensors are placed at the starting point. And I'm asking the question that the water pipelines are coming under the ground. If any leakage is at the ground level, how can you identify? If we place the sensors at different places of the pipe.
But that's true, what you said is right. But what we did is the starting and then ending. So in between, if there is a thing, I can put multiple sensors, but it's going to be costly. Because of the cost, we confine to that. With that itself, before putting that, So when we installed, we identified 36% of the water is getting unaccounted. Whether it's overflows or whatever it will be, it is unaccounted. By intervention of the municipal corporation officers and the actions, if that data what is taken, it is brought down to 9%. That means 25% of the water is without adding any infrastructure available to Vijayawada.
Actually, when we are walking in the road, so many taps are opened and which are not closed. So because of that actions also the water is wasted.
Because we can do lot of things, but what needs is a lot of investment. So whether the investment is going to be that is going to give that value. That's what I said. Benefits divided by total cost. So if the cost is more, the benefit is less. I am able to save only 1 KL. That means the benefit is less and the investment is a lakh. That may not be meaningful. Say in India we don't have that much luxury to spend more money. So that's where we have to be careful in looking into
optimize the
optimize. That's what I said in the value. Look into that every aspect. We have to look into the value today. If you start looking everything in the value dimension of this, all this another dimension, what is happening in the world is the truth is coming out. With the digital transformation, truth is coming. Truth is the critical for the any growth, any development. Are you understanding what is meaning of the truth? Many times people get confused with two dimensions. Dharmamu, adharmamu, truth. Truth is, we are talking about nizam. Fact. Whatever that I did bad, but it's a fact. That is, if you understand that fact, you'll be able to improve it. So you might be doing good or bad, that's not the issue. We are not talking about this is the better way to do it, this is the bad way to do it. But people get confused between these two and they corrupt the truth.
can make both the side as conducting glass substrate. So conducting glass substrate we have taken both the sides. And here photoanode. Photoanode, for the formation of photoanode, the prepared high surface area titanium nanoparticles are there, that we are going to coat it here for the coating purpose. Okay, the powder how can we coat? The powder we can use buttering and all, right? But here in the high-surface solution, what we can use is make it mixed with the polymers, and make it as a paste kind of form. That paste is applied. Then once it is coated, the paste is applied, then it will stick onto the surface. But what is added here? We have added the polymer and other solution. It needs to be dried. It has to be removed and okay. So it will be in the form of like a paste form. Need to have films. Okay, that formation we need to get heated. Okay, then we are heated up to 400 degree, 450 degree. Then that whatever the additive polymers we are making it for the binder, that will be removed. Okay, then once it is removed, this is added with the dye. Okay, for the formation of dye-synthesis vessel, the dye will be absorbed. Okay, because of the porosity, more dye will be absorbed. Okay, and once the dye solution is done, photoanode is done, counter electrode. What we are adding the catalyst, platinum catalyst, very less percentage, 0.05 molar amount of platinum will be added here in order to get the electron in fast. Okay, so once it is done, once it is light is fallen, then electron will be generated. Once it is electron is generated, but immediately what is required, that gap has to be fulfilled. Okay, that vacuum has to be fulfilled, then whatever it is splitted, that will be again it will be regenerated. That is recombination will be occurred. True, but it did immediately. So we are in the need of electrolyte required. So this what is the electrolyte is role is oxidation and reduction. So giving the required electron, that will be fulfilled. Okay. Then this movement of electron will come back now. Okay, here it is oxidation. Then here immediately whatever the electron is needed, that will be given. Then again it will be collected, the outermost. So it is oxidation and reduction process. Okay, continuously happen. So flow of electron also will be there. Here it is also recombination also will be reduced. Okay. So this structure we are going to make now. Here, but what happened in each and every stage, recombinations will be there. Okay. Because of dye, some amount of electron will be recombined. Because of electrolyte, some recombined. Okay. So we need to ensure that this recombination in the dye, recombination because of electrolyte has to be reduced. Then only the efficiency will be. We are getting the good efficiency. Sand, it will be more porous. Okay, you will see that movement of. Okay, this more porous, very less, more amount, but very less weight. Okay, so I told you like TiO2 also needs to be prepared from rutile sand. It's not in white color. It is always coming like the light yellowish. Okay, this is also more porous. Okay, right? Okay, so these are all the materials. Once you made the materials, what is required? You need to make it convert into the paste form. Paste you can make it with the stirrer. Okay, though if you want to uniform coating. Okay, so uniform coating done. We can mix with the polymers. What are the polymers and what is the percentage of the things I have given to the list. Okay, so once you made big small balls, it is kind of ball mill, but not the actual ball mill. zirconium balls. Okay, you can keep it on the roller. The roller which we can use is like in the hospitals, like just this thing, like blood samples. They use one. In that you can keep it for 24 hours, 48 hours continuously. That will be rotated. Okay, then uniform mixing will be there. Okay, for now what I am doing is for coating purpose. I am not using this because it has like minimum 48 hours and the optimization of paste itself. Some process is required. So this is the way we used to make the paste. Okay. So this is dried. Some of them is dried. Okay. So like whenever you are working, then you have to make labeling that you are used to make. Right? So label after over the label you used to make sellotape to avoid again it will be gone now. Any water or anything is there. So now what we made, window is created. Now we are going to apply the paste. Right. You can use this side or this top or this full corner. So I am using this one just once. Apply. Once you are applied, that is more than sufficient. If you feel somehow you want, just you fold it little bit. Right. Okay. But enough. Okay. What you can do is can take this one. Right. So this was done now. Now you can take, if you are taking, what will happen, the corner which is not sticking properly, that will become out. So you can use minimal drying with the hair dry. What is the thickness of the scotch tape? That thickness only was, because the window has created and they are applied. So that thickness of the scotch tape level it was coated. Just you have to dry little bit, not more. Okay, done now. So once it is done, you are supposed to be remove slowly. Done. So coating was done. Okay. Please handle it very carefully, otherwise it will jump. Because of the force in one side, another side will come out. Okay. In next I itself is able to see the window which we have created. Done now. So this space is beyond that the whatever you coated. So space from the coated and then window, because need space for the electronic active locations. Okay. Then you want to keep it here, the drilled one. You just keep it here. Keep it and make it the binder. Keep it somewhat here. Yeah, keep 250. Done. Okay. Click. Once if you are keeping that, just in 120 degree, that will be fixed, attached. Okay, once fully attached. Okay, now what is required? We need to pour the electrolyte. That electrolyte pouring with small injector or with like what you call pipette, micro pipette. Just pour it on the small cut window here, right? Okay. Once it is attached, then you can split it because it was attached. After that, you have to this small piece. This is attached. After this, you attach here. Now the temperature was heated. Come here. See the difference. Zoom. Change in color. Is it visible now? Okay, the coated things was there. Drop casted platinum with this trying become black in color, and which we have coated screen printed is brown in color. It is trying to degrade the excess amount of polymers. Okay, you'll see after 450 degree we will keep as it is. I'll bring this to lab. What is the time now? 1. We'll wait for 15 more minutes. We'll see any color changes are happen or not. Then we will go.
The schematic of that picture is here. So one part is acting like a solar cell, whereas the other segment is acting like a strain sensor. So when they are going out, when this device gets exposed to sunlight, so it started to work like a solar cell, and when they are able to bend and release, so that time it started to work like a strain sensor, started to detect the different ratios of strain. So when there is a solar cell inbuilt on it, even instead of putting a thin level strain sensor, even if you put a commercial electronic device, that device also would be powered up. And then again, this is one other application. So fiber-based wearable autonomous energy harvesting and storage devices. You see that how the impact of this research. The previous work got published in Nano Energy, and this work has been published in Science Advances. So this is like the fiber-shaped device. So what they do is, they take two different fiber yarns. So one of the material, copper. So copper yarn which is acting like an electrode. So they took the other two material. One would be of one polymer which have negative triboelectric coefficient. The other would have been a positive triboelectric material. When these two materials start to create friction, so the charge will transfer from here to there. The transfer of charge is nothing but your electricity. So in a fiber, they have done that. And when you do hundreds of fibers and when you knit it, you can make like a cloth. So that kind of a structure has been taken and that has been worn on here and here. So when we walk like this or do like this is the place which we get the friction at first. So what happened? The places started to get the friction and eventually they started to generate electricity out of it. So now present day scenario and future scenario would be like this. The present day is the first generation devices that what we are using at our present day. We are using the smart watches, smart gadgets, virtual reality glasses that we are putting and playing the VR games and experiencing some kind of a VR experience. What we can able to do in reality, we are doing it through the VR glasses and Apple Watch and everything we are using. So again, the first generation sensors. The first generation sensors are what that we are using present day. It's like the watch have a sensor which can able to count the number of footsteps that you are walking, the number of steps that you are running, and your pulse level, your ECG electrodes which detect all are first generation sensor. Now with the introduction of this wearable electronic concept, that too flexible and wearable, although they are wearable, but still it's a first generation device. Why I am insisting more on that? It's because they are bulkier in size. Okay? So when you go for this next generation devices, these devices would be directly worn on your hand or you can wear it like a cloth. So this is, so now there are some research which is going ahead like athlete monitoring, sports monitoring like. So what they do is their jersey or the t-shirts that they are wearing, right, on the t-shirt itself, knitted sensors or wearable sensors are coming. So how long they could be able to run, what is his capacity, and everything can be calculated using that. No need of a bulkier device to put it on the hand or in the dress. You might have seen that in cricket what they do, suppose like some guy is doing a bowling action which is illegal. So what they do is they put a number of sensors on his body and they will ask him to bowl in a separate room like this. So what they will do there is to calculate that they put number of cameras around. So when they put the camera around, when they put the sensor and the camera around, so again there will be a concern called privacy. So you can't do like that, right? So when these kind of sensors which is coming like a t-shirt, so you can directly wear on it, no need of camera, remove all these cameras and bulkier devices, some kind of a bulky devices when you wear, so your body movement or force would be restricted because of its weight. So for example, there is someone who is like paralytic or they couldn't able to, someone's hand or limb have been broken due to their accident. When they get rehabilitated to recover from that, these kind of sensors could be able to predict very clearly or easily about their various stages of rehabilitation. Whereas the prosthetic limbs are presently used, they are heavy. Someone wear a robotic arm or leg, you try to lift it, so that weight itself he could not able to warn. How we can able to predict it easily the degree of rehabilitation. So the next generation devices are going to be on-body wearables. Few products are already coming out, so still the power source is one of the major problems here. D33 meters are directly there for measuring, where if you make the pellet of the ceramic piezoelectric material and if you directly put it on the instrument with the electrode, it will directly give you the value. But the other way is put it on the PE loop tester to calculate the PE, remnant and saturation polarization can be calculated. From that also we can derive the D33, but that is difficult. D33 meter can give you the D33 value easily, directly.
So for going for, so you have to be emphasizing piezoelectric.
Piezoelectric coefficient, usually, because that determines the piezoelectric property of the material, right? So because PCP even reported 700 picocoulomb per Newton also. Giant piezoelectricity, like that one ACS paper, they have reported 650, 750. Single crystal PLTA-13 was also reported. But they were not producing high performance in outside atmosphere. That study have been carried out with the Institute TEM. They have studied with single crystal material. Single crystal material can produce good piezoelectric, but they can't be stable for a long period of time. So with respect to ceramics, then we need to go for analyzing the piezoelectric coefficient.
Which affect the thickness of
Which one?
piezoelectric coefficient.
No. Thickness and the coefficient are not related to each other. They are two different parameters. So thickness is like if you go for a spin coating method to optimize that one, or if you go for a tape casting method to go for, because tape casting what happens is like you will have the doctor plates which they by default they will define 50 micrometer or 100 micrometer thickness. So with that you can directly take into the thickness, because all we are fabricating nanomaterial. So thickness doesn't affect in that way.
But must be university, not a separate institute. There is no any institute concept through NEP 2020. Second is research intensive universities, where they will give more concentrations for the research rather than the teaching. That means the teaching will be happens through research activity. Best example, you may hear about Tata Institute of Fundamental Research, right? Triboelectric Institute of Fundamental Research is there. Triboelectric Institute of Research Center is going to be available. Baba Atomic Research Center is available.
So these are the institutes actually. So that they will have more concentrations on the research rather than the teaching. So if you're going to ask that teaching is not happening, yes, it's happening, but through research. And third category of institute which they want to establish in India is nothing but autonomous institutes. Why autonomous institutes? They're giving this much of importance. They say either institute must be a university or else should be an autonomous institute. Higher education institute should be in this category. Why they are stressing autonomous institute very particularly? What is the purpose of stressing the autonomous institute, increasing the number of autonomous institutes in India? What is the purpose? What is the difference between the institute which comes under a university and the institute is comes under autonomous? It doesn't mean that if it is autonomous it will not come under university, it is also comes under the university. But there are some special things that are available with autonomous institute. What is it?
Flexible privileges with reference to their curriculums.
Yeah?
Flexible privileges to fix their curriculums.
Hmm.
And as well as there will be privileges on question paper settings and as well as evaluation procedures.
Question paper settings, evaluation procedures and all, it's going to be support of the teaching learning process. But as you said earlier, curriculum modifications we can make it in very flexible manner. If you are an institute which comes under, let's say for example, a maximum from Tamil Nadu or Andhra Pradesh, wherever it might be across in India, if any institute is going to be attached with one of university, so for any kind of syllabus change, they can do it. Right? So this can be brought through this OBE, outcome-based education section. So outcome-based education start from the, what's the purpose? To make the education to become more standard. As I said, what is the outcome of your educations? What are you going to learn? What are you going to gain out of it? Through which we can able to make our curriculum on the state of our technology. Right? We can make the curriculum on the state of our techniques actually. Still, is it okay if we study about the vacuum computer? Computers introduced in the vacuum tubes, right? At the initial time. Computer means it's one big room size actually. Is it okay still you are studying about that one? Is it okay? Students, computer means this much big room will be there, vacuum tube will be out here to there and that to here. Is it okay to study about this, the old technology? No. I'm not saying that it doesn't require old technology. We need some fundamentals and along with that we should be in the state of art. Accordingly we should train the curriculum. That is what OB is insisting. Always be in the state of art. Don't be lagging. And once you have a standard of education and curriculum properly and see that are you meeting the requirements of getting the accreditation process. Accreditation is nothing but certifying that institute is following the outcome-based education. That means they make sure that students are employable and they make sure that students are learn something while they are leaving from the course.
Energy harvested. So we all are aware that since for past 4 days we are discussing about various energy harvesting methods or systems different we are going to see. So what is the main problem with this particular, why we go for this is the energy. So there is the in future, there is an exhaust of the conventional energy sources. So there is need for it or there is a necessity, we need to search for the alternate methods which provide the energy sources. So as a part of this, the energy harvesters were developed, so which forms a usable energy from unconventional sources. So since there is abundance of energy available in the environment, so there is not, we need to use that energy to the usable, so that there will be two different of scales. That is why we have the large scale energy and as well as the small scale energy, where we can apply according to the applications, we can choose
everybody we are using the mobile phones, we are getting signal from the towers and Wi-Fi, and we have a number of dedicated sources, RF dedicated sources are there. Because of the our ambient signals are available, because that's why I'm ready to design the RF energy harvesting antennas for the small IoT devices. Thank you for the opportunity, and these are the available frequencies we have available. In addition to that, last year onwards we have 5G also in India we have installed. We are getting the three types of bands. First one is low level band, that is 900, 700 bands, and mid bands 1800, 2100, 2300, and in addition to that M78, M79, M77, these are also plays a major role in the RF energy harvesting applications, because signal is available for the 24/7 hour. So my field is ferroscrete photovoltaic, so I want to give an overview about what about the material and what are the applications they are doing and what are the problems they are struggling. So first of all, what is meant by ferroscrete? There is a crystal structure ABX3. A and B are the cations and X is the anion. A's oxygen state is +2 and B is +1. And X is -1 material, so it will be calculated as ABX3, so +2 +1 3, so it will be balanced as ABX3. Basically, A is materials, all the materials are used for as A is cesium, rubidium, MEI, methylammonium, and FEI, there are materials they are used. And for B, they are using, mostly they are using lead, and now research is going on tin. So, material is for B is lead and tin. Generally, they use for X is chlorine, iodine, those kind of material. Halogen groups they are using for the X group. So, we can change the materials as like we want, but there are many parameters. The basic parameters, the stability of that structure. So, the structure is very important for the ferroscrete structure, because if we didn't create the T is a tolerance factor. So how we can calculate tolerance factor is based upon the radius of the atom we are using. So it should be in the range of 0.85 to 1.11. So if it in that range, we can use, there is no, we can use this type of materials. So we can change any metal. For example, we can change A, we can change B. But the thing is, the tolerance factor should be in the range of 0.85 to 1.1. So if we check now, we are, I am working in the field where I can change the material, A material.
LEDs. So typically, that one pixel is consisting of these three primary light emitting diodes: blue, green, red. So what would be the typical structure of each diode, each organic light emitting diode? So you can see that each organic light emitting diode will be consisting of the thin organic layers of thickness of nanometer thick. So you can see that typically there would be different types of layers. In order to increase the efficiency, the typical OLED structure will be consisting of minimum 3 layers. Early devices which was fabricated with a single layer, and later it was developed in order to increase the efficiency. They have made minimum 3 layers, and depending on the energy level diagram and alignment and the requirement of the facility and in the efficiency requirements and the external quantum efficiency, they have made into several thin nanometer size thick film, and they have made the organic light emitting layer. Typically it will have one electron transporting material and one hole transporting material and one light emitting material. If you consider this, if you take this hole transporting layer, the molecule which will have the higher hole mobility will be used as a hole transporting material, and the organic molecules which will have the higher electron mobility will be used as an electron transporting layer. And typical light emitting layer should have the property of hole mobility and higher electron mobility, and there should be a requirement of
recombination zone should be formed, and there the electron and the hole pairs will recombine to give the light emissions. So these are the typical requirements of organic light emitting diodes. These thin organic thin films will be sandwiched between the two electrodes. One is the highly reflecting cathode, typically aluminum, and highly transparent conducting of metal oxide. So what I mean to say from this part, it is nothing but when the UV energy is striking and the visible light is striking the organic molecules, there will be a transition of electrons, and the electrons will go to the excited state in the molecule, and the excitons electron hole pair will be generated in the molecules. So this electron hole pair generation is very important for the for the electrical conduction in the organic semiconductor molecule. So, as I already mentioned, the p jet orbital or p orbital electron will be laterally overlapping with the adjacent carbon atoms, and hence this bonding is a weaker bonding. This weak bonding p orbital, that is the pi orbital electrons, will no longer confined to any adjacent carbon atoms. So it will be keep on flipping between the other carbon atoms. So pi bonding, that is pi bonding will be keep on flipping throughout the length of the molecule. So throughout that length of the molecule, pi orbital will be flipping. This flipping of the pi orbital electrons will constitute the charge transport in the organic molecule. So in the organic molecule, charges would be transported from one end of the organic molecule to another end of the organic molecule through the flipping of the pi orbitals. Whereas in case of, as you know, in case of inorganic based semiconductor, how the transport is taking place? It is taking place by the movement of the free electrons throughout the volume. Once the electron comes to the conduction band, there is no restriction for the electron to move throughout the volume of inorganic basic semiconductor. Whereas this is not the case with the organic. Organic molecule, within the conjugation length, the charge carriers will be transported, and that is nothing but the flipping of the pi orbital electrons. So pi orbitals will be flipping between the adjacent carbon atoms, and hence charge will be moving from one end of the organic molecule to the another end. So the pi orbital electrons, by flipping, it will be looking like a delocalization of electrons. You cannot locate the electron at one particular place or one particular carbon atom. It will be keep on flipping between the adjacent carbon atoms, and hence the p z orbital electron is considered to be delocalized above and below the molecular plane of the organic semiconductor molecule. So above the molecular plane and below the molecular plane, this will be flipping, and hence in this conjugation length, the charges will be, the probability of finding the electron within the conjugation length is maximum. So you cannot say that the bonding is fixed at, between these two carbon lengths. Like in inorganic case, there would be defect energy states will contribute to the non-radiative energy transition. In the same way, here too, there are non-radiative transition. One is called as a frontal energy transfer and the dexter energy transfer. The difference between the ranges. So in case of frontal, what will happen? The excited donor molecule, that is a host molecule, will in the electron in the excited host molecule will make the transition to the ground state. The energy would be emitted, and the emitted energy would be absorbed by the acceptor molecule or the guest molecule. And hence typically there would be a transfer from host molecule to the acceptor molecule, and hence there would be energy transition from host to guest. And the host molecule will come to the ground state, and the acceptor molecule will go to the excited state. And in case of texture energy transfer process, in case of texture energy transfer, this is a very short range energy transfer process. So electron would be just transferred from excited state of one host molecule to guest molecule. From the host donor molecule to accept or guest molecule, the electron will be typically transferred from one energy level to one system to another system. So in this way, the donor host molecule will come to the ground state and acceptor molecule will come to the excited state. So this is telling all about how the charge will be transferred from one molecule to another molecule in an organic field. Okay. So, and as I already mentioned, there will be a transition through the non-radiative transition, as well as the electron can transfer from one non-radiatively from one molecule to another molecule. If it is a short range, that is called the texture transition. If it is a long range, it is called as a Forster energy transfer.
We are all 6 days, like day 1 to day 6, whatever we are proposed and whatever we have planned, it is executed and come to that conclusion and ending session of our program. Once again, I am welcoming you. Now I request Dr. Vivekananthan sir to summarize the 6 days of our FDP program.
Good afternoon to everyone. So now we come to the formal valedictory session of our 6-day FDP program sponsored by ATAL AICTE. So we have started this FDP program with the theme of one of the core areas of the ATAL, which is wearable energy harvesting, particularly focusing on wearable devices. So with that, taken that area as the theme, so we have proposed the title Emerging Technologies on Wearable Energy Harvesting and Storage Devices for Driving Innovative Sustainability. So first of all, I would like to thank the AICTE ATAL Learning Academy for supporting this FDP program. And then I would like to thank the KLEF management and all the functionaries for their constant support to conduct this FDP program in various aspects. So here are the list of our participants. So total for the 6-day program, we had 10 participants. So in that, like, we had 8 of the participants, 8 of the guest speakers from outside of KLEF and 2 people from the KLEF. So it is like these faculties are from various IIT, NIT and other institutions, like industry people also have been tied up with this 6-day FDP program. So to summarize the event by day, so the first day of the event was on the topic of photocatalysis in solar energy harvesting, which can be heterostructure, nanostructure, facilitate effective photoexcitation, separation and efficiency, by Dr. M.B. Shankar, Professor in the Department of Material Science and Nanotechnology, Yogivenama University, Kadapa. The session was completely focused on heterojunction materials for photocatalysis process and then solar energy harvesting process. So the session was completely interactive and almost the participants have interacted with him. In addition to that session, he also have carried out one more session of technical writing of the manuscripts, how to crack the high impact journal with your writing and how to present your results in a way to crack a high impact publications. So on the same day we had our chief guest, Dr. Sathish M, who is the principal scientist in CECRI Karaikudi. So he had his session which titled Nanostructured Materials for Energy Storage and Applications. So in this session he have discussed widely about the supercapacitor. He started with the basics and then he went until the end user applications in respect to the materials as well as the applicability of the supercapacitor in various fields. On the day 2, we had Dr. Shankar Rao, who is the Managing Director of NanoSol Energy Pvt Ltd. So he had presented his research on emerging technologies in renewable energy and its applications, opportunities and challenges. So this session was very interactive where he was focusing about the step-by-step way of how to use the renewable energy in various applications and what are the opportunities available with the renewable energy and what are the present day challenges that we are facing and which we can able to focus towards a new direction of research into it. So after that, the day 2 session was having one more speaker from NIT Warangal, Dr. Rakesh Kumar R, so who was talking about powering the future, exploring small-scale energy harvesting for innovative applications. So this session he have introduced the Triboelectric nanogenerator, and its applications very widely on various fields of research into it. Then the next day we had a speaker from IIT Roorkee, so Dr. Kaushik Parida, so who was talking about the next day Triboelectric nanogenerator, where he was focusing on the wearable Triboelectric and wearable nanogenerator technology for sensors. So followed that we had one more session which we had from Mr. D. Ramakrishna, who was the CEO of Efftronics Systems Pvt Ltd in Mangalgiri. So where he was addressing all our participants on electronic system design and manufacturing. So almost 70 of our participants have moved to their place, and we eventually had one of the industrial visit over there after the talk. So next we had the speaker from our KLEF, Dr. Aravindhan S, who was talking about his research on nanostructured materials for photovoltaic applications, where in the later day we had the hands-on session with Dr. Aravindhan on how to fabricate the dye-sensitized solar cells. So the next was the day 4. The session was carried out by me on wearable energy harvesters and self-powered devices towards energy autonomous sensors, where I had a chance to discuss with all the participants the research that I am carrying out at the KLEF about energy autonomous wearable sensors. On the day 5, so we had, as per the protocol, so we had a session on National Education Policy 2020, which was carried out by one of our faculty colleague and the Associate Dean Academics, Dr. Aravindhan Alagarsamy, so who was narrating about the new education policy, how it's going to be implemented in the present and future of our education system. So after that, the same day we went for the industrial visit to Efftronics Pvt Ltd company. So where we had the industry live problem solving and project demonstration. So we could able to have a chance to see the entire process from the PCB design to the end application part, what has been carried out in the Efftronics Pvt Ltd. So mostly we were seeing about the data loggers where they were applying in the Indian Railways. So they are predominantly supplying that to the Indian Railways, and they are one of the constant supplier of data logger to the Indian Railways throughout our India. So day 6 is the final day, that is today. Today forenoon we had a session with Dr. Thangaraju, professor in Department of Physics at NIT Warangal. So he was talking about the research on organic semiconductor and organic inorganic hybrid thin films for optoelectronic applications. So in the entire 6-day FDP program, so in addition to the expert members talks, so we even had the lab demonstration and hands-on experience for 2 hours on each of the day. So where we have covered nanomaterial preparation and characterization, nanofiber preparation using electrospinning technique, Tribound Piezoelectric energy harvester, fabrication and testing, and then DSSC fabrication and testing. So which has been carried out at our Center for Flexible Electronics and Center for Advanced Energy Studies in the C block. So in addition to that, every morning before the start of the session, we were having article discussions, teaching practice, and the reflective journal, which was given as the task to the participants which were who were participated here. So overall, as a statistics, the comprehensive assessment for the entire FDP for the participated 50 members, so overall we have received 90 participants. In that 30 have been withdrawn, and we have removed few because their area is not matching with this. So in that the criteria is given for the 50 members who are participating regularly, so out of which we have received more than 80% of attendances. So the attendance minimum we gave 80% of attendance with the weightage of 20%. One assessment which is combination of MCQ, short answer type reasoning based, which have a weightage of 10%. Then page article summary per team, so we have segregated into team and then we have given them that one. Then teaching practice, which have a weightage of 15%. Yesterday we had several of the participants who are presenting their teaching practice here, and few of the researchers, research scholars who came for our FDP also presented their research work here for a short period of time. And then the report we have received for the industrial visit that we had yesterday, which have a weightage of 10% in this overall FDP. And then reflective journal at the last session, so which have a weightage of 15%. So I would like to thank the entire participants to actively engage in all the 6 days without missing any of the sessions and gain their continuous knowledge here. So I would like to receive few feedback from the participants. So now the session is open to the participants to share their feedback on this 6-day FDP program.
KLEF for accepting my application to participate in this 6 days faculty development program. So this 6 days FDP program was very useful for me. And this in this 6 days period, as a research scholar, I introduced to many research fields which will be related to my field. So I will use this technologies in my ongoing my research. So it will be really helpful for me, sir. Especially Triboelectric nano generators topic was very useful for us, and the preparation for this FD program was very uniform in manner, sir. Like that, why I am telling this, sir. First, the arrangement mates first they introduce about the Triboelectric nano generators, then they move to the next session where they tell that how we can use the nano generators in wearable application in human parts. So in that manner, it will be a useful manner. So we learn about a lot. And Dr. Sathish gave us an overview about the supercapacitor field and the real-time and moreover all the research persons topic oriented, they all give various fields, but in the end they will give us insight to how we can use that technology, supercapacitor, Triboelectric generators, Piezoelectric effect through the wearable energy devices. So that is very helpful for us as a research scholar. So thank you for this opportunity, sir. Thank you.
Good evening, respected dignitaries and dais and the participants. Myself, Krishnaveni, working as assistant professor in JNU Kakinada in AC department, and also I am doing here a part-time scholar in the KLU University, and under the guidance of our Vivekananthan sir. And I have attended that 6TP workshop, FDP faculty development program. So on the emerging technologies on wearable energy harvesting and storage devices for driving innovative sustainability. It has helped me to gain the knowledge regarding the fundamentals of materials, and also some the devices, those are the piezoelectric nano generators, and next triboelectric nano generators, and some solar cells, and next some storage devices such as that supercapacitors. So using that PENGs and tanks will use for that wearable devices, wearable energy harvesting field we can use. And also parallelly in every day we went to labs for doing that hands-on experiments, and there I have learned so many things in lab session also. And next and we went to some industrial visit of the Efftronics lab. So there so it is they have told that so what is the present technology happening in our world. And next, it is helped to that it will reduce the gap between the industries and institutes. So the overall the FDP sessions are it is very good, and it is helpful to our research also. So thank you for giving this opportunity.
Good evening everyone. Myself Dedipya, working as full-time research scholar at physics department in KLU. So first of all, thank you so much, sir, for organizing this FDP. It's not only useful to faculty, but it's also useful for research scholars. So mainly I have liked the sessions in lab because hands-on experience, you have explained everything very clearly to us. Though it was a very different area from our research, but we gained so much knowledge. We have we have learned everything by touching the instrument, and so many things we have learned. And not only that, industrial visit also in different other colleges, it's not possible to interact with everyone, but you made us to interact with everyone, and we have gained so much knowledge about that industry also, and about job opportunities also we have gained some knowledge. So thank you so much, sir. We have ready to participate in more events like this. So thank you so much for giving this opportunity.
Good afternoon everyone. Myself Bujji Babu from SC University Tirupati. Actually I came from the from Vijayawada. Thank you for the opportunity, for giving me opportunity to participate in the for 6-day FDP program. I don't know all these things, what is the energy harvesting from the different types. Actually, I am working on the RF energy harvesting with the help of the diodes, the conversion of the RF to DC signal only. I don't know all those things. This is the Triboelectric, Piezoelectric, and one more thing I will tell you. Actually, all the sessions are very informative, and practicals also every day conducted in the laboratory. It is very interesting. Why? Because sir are very enthusiastically explaining all those things when preparing the materials and preparing the LEDs. Thank you for the opportunity. Thank you, sir.
A warm good afternoon to one and all present here. I am Indumati from SRM University. Overall, the 6 days FDP program was incredible, and the speakers for the technical sessions were experts from their own field, and hands-on training. While we talk about hands-on training, we experienced a lot of fields like from supercapacitors to piezoelectric, triboelectric generators, nano generators to dye-sensitized solar cells. And of course, the industrial visit was astounding, and we gained a lot more knowledge in production, and the staffs were very welcoming. And finally, I would like to thank the coordinators, Dr. Arun Mehta sir and Dr. Vivek sir, for giving us this wonderful opportunity. And saving the best for the last, I would like to thank the fellow scholars of KL University for their warm reception. Thank you.
This is much useful to the researchers. Not only to the faculty, someone mentioned that not only to the faculty, for researchers, for research scholars especially, it is very useful. So try to attend these kind of programs and gain something out of it. It is not the getting a certificate of FDP from some institute and showcasing that to your institute and spending some 5 days and 6 days outside. So those things, okay, enjoy those things, that is okay. But final ultimate thing is if you want to survive, my word, take it underline, if you want to survive in future, the only research component only will help you. Other components everybody can do. Research, administration, academics, all these kind of things, everybody are same. But the only component that is differ from the other people to you is the research. So don't neglect that particular research. Try to improve the things, try to learn the things, because whatever things that you learn today, after 6 months it will be outdated. So try to attend these kind of programs and learn more things, and form a small group and work and get the good results. So with this, I thank once again the coordinators for conducting this particular program in an effective way at KL University and completing in a successful manner. So thank you to all.
Conclude the sessions with word of thanks. That is most important for encourage to others also. Now I request Vivek sir to give word of thanks.
So first of all, I would like to thank the KLEF functionaries, management, and the deans for providing us the opportunity and the support to conduct this 1-week faculty development program on emerging technologies on wearable energy harvesting and storage devices for driving innovative support sustainability. I am very happy and grateful that eminent professors from NIT, IIT and CSIR laboratories, central universities and industrialists who came forward to share their knowledge and experience with us, with the chance for the participants to gain the knowledge from them. I thank ATAL, and I would like to express my heartfelt gratitude to our Honorable President and the management and the functionaries for their support in organizing this FDP program.